As I mentioned, we always start troubleshooting at layer 1, and it doesn't get any more layer 1 than cables, and that's what we're going to talk about here. I've also got some great real-world versus theory information for you, and a study tool, that free study tool even better, that is really underutilized by a lot of CCENT and CCNA candidates. I want to make sure that you are overutilizing it, because like I said, it's free. Now let's talk about some cables. We're going to use a very simple network for this demo. We've got a host to switch connection and a switch to switch connection. And let's concentrate on the first one, the host to switch connection. Now a PC's network card is going to send signals on pins 1 and 2, and a switch sends on pins 3 and 6. In turn, the PC receives on pins 3 and 6, and the switch receives on 1 and 2. So there's no problem there. It's not like the PC is sending on a pin that the switch is also sending on, and then we'd have signals crashing in the middle. So this means that we can use a straight through cable to connect the PC to the switch. Now the cable comes from, the cable name comes from the wires inside the cable, because of course anytime you look at any cable, it's like, well, of course it goes straight through. It goes straight through from one end to the other. But what we're actually talking about are the wires inside the cable. If we're using Ethernet or fast Ethernet for this connection, which in this case is a safe assumption, especially with the PC to the switch, we're going to have 4 wires inside the cable for fast Ethernet and Ethernet, and each wire goes straight through from one end to another. And again, you might think, well, how else is it going to get there? What I mean by straight through in this situation is the wire connected to pin 1 at one end goes straight through to pin 1 at the other end. The wire on pin 2 goes straight through to pin 2 at the other end, and the wires on 3 and 6 go straight through to those pins respectively on the other end. Now, if you enjoy making your own cables, or you're making them for a class or for whatever reason, and you run into some kind of connectivity issue in your lab, I guarantee you it's that homemade cable. It could be damaged, but the real issue could be that one of the wires in your straight through cable is crossing over to another pin. Now, Gig Ethernet can use straight through cables as well, but to carry that data it does follow, we need some more wires. So where Ethernet and fast Ethernet have 4 wires inside the cable, Gig has 8. And in a Gig straight through cable, I hate to insult your intelligence by telling you this, but one wire goes from pin 1 to pin 1, one wire from pin 2 to pin 2, and so forth for all 8 pins. Now when I mentioned crossing over there, crossing over is not all bad. As long as you are trying to make a crossover cable, not a straight through cable. Because sometimes we want the wires to cross over, and that's where the name crossover cable comes from. Crossover cables are necessary anytime we're connecting 2 devices of the same type. And in a typical network, where is that almost always going to be? With switches. And when we go through switches in this course, you'll see why interconnecting switches is so common. They've got to be able to talk to each other inside a switch network, and these switch-to-switch connections are called trunks. But we can't use a straight-through cable for a switch-to-switch connection because they use the same pins to send and receive. So then you got a real mess, because you got 2 wires that both hosts are sending on, so obviously the data is going to crash in the middle, and pins 3 and 6 are just going to sit there and listen for data that never comes. That sounds kind of sad, so we don't really want that. Communication between the switches, again, it's made possible by a crossover cable. The 4 wires inside the cable cross over from one pin to another inside an Ethernet or fast Ethernet crossover cable. Wire on pin 1 goes to pin 3, pin 2 to pin 6, 3 to 1, and 6 to 2. Now with that set up, when a switch sends data on the 2 pins used to send data, 1 and 2, the switch on the other end of the cable receives the data on pins that are used to receive data, 3 and 6. Gig Ethernet crossover cables, they have those same wires cross over in addition to these, 4 to 7, 5 to 8, 7 to 4, 8 to 5. It probably would not hurt you to have those down for the exam, especially the first set for Ethernet and fast Ethernet. I don't know as they would go as far to ask you about gigabit Ethernet crossover cables, but if they do, again, it's not a bad idea to memorize these particular lists. Now, let me give you a little real world versus theory chat, because some of you are watching this and saying, well, Chris, that's great in theory, but I know that I used a straight through cable to connect 2 switches and it worked fine. or I know somebody who says they did, and the book says they shouldn't have been able to do that. Well, it depends on which Cisco switch model they were using, and this is, I don't want to say it's off the record because I'm speaking directly into a microphone, so that would be kind of silly. But this is something you have to leave behind for your exam, but I want you to know about it. Most Cisco switches today will recognize what you're trying to do when you connect them to each other with a straight through cable. They're going to say, hey, wait a minute, that's another one of my brethren or sister in switches there. This admin meant to use a crossover cable. Maybe he just forgot to order one. Maybe he doesn't have one, etc. I'll just make this act like a crossover cable. I'll pretend it's one. And the switch will dynamically adjust itself to make the straight through cable work. It's actually pretty cool stuff. But again, when it comes to your tests, you need to forget about that. Be clear on when you would use a straight through cable as opposed to a crossover cable. If the devices transmit on same pins, which means they're the same device, you use a crossover cable. If the devices transmit on different pins, you use a straight through cable. And you can see I added a router to this one because you will use a straight through cable for a switch to router Ethernet port connection. You will use a straight through cable for that. Now, regardless of which type of cable you're using, these are going to end with RJ45 connectors, and they kind of snap right into place when you connect them to a PC network card or a switch router Ethernet port. You might not hear the click because your wiring closet may be so loud, or all your routers and switches collected together in your lab. You might not hear it, but you'll definitely feel it when you snap it in. Now, I want to show you what one of those looks like, and then I want to talk about that study resource we were discussing earlier. And this is just what an RJ45 connector looks like. There we go. And we've got, you see the little connector, little snap right there. You can actually see the colors of the wires in there as well. And again, you'll feel that just snap right in, and you're good to go. I definitely want to credit that picture. Thank you, David Monio. I hope I didn't butcher your name too badly under the licensing here for that particular picture on Wikipedia. So thanks for that. Speaking of Wikipedia, this is the study resource that I want to mention to you, and a lot of people overlook this. But one question that I get regularly is, hey, is your stuff all I need to pass the exam? And of course, the goal is not just to pass the exam, it's to thrive after you pass the exam. But I always tell people you should always use at least a second source of information for your studies, even if the first source is me. Okay, and I appreciate you making me your first source, but you should always use another source of info. It's just a more effective way to learn. And I do that whether I'm taking a tech exam or a non-tech exam. I'm not just going to get one book and read it about the Roman Empire. I'm going to get a couple, and I'll read the Wikipedia page on it. Now, I'll be the first to say that Wikipedia can go above and beyond as far as the level of detail goes for the CCNA and CCENT exams. The encryption page, I think I'm still working on that after reading it for 3 years. It's very, very technical. But the key here is you've got all these great illustrations out here. You've got good, solid explanations. Lord knows Wikipedia pages are linked like crazy, because if I want to read about 10BASE-T, then I just click that and head over there and start reading about Ethernet over Twisted Pair. So it's a fantastic study resource, and I really do urge you to use it. I find a lot of candidates kind of forget about it. And of course, more pictures are always great too, and it is well illustrated, because with things like crossover cables, you can look at the numeric list all you want to, but when you see it, that's when it really does click for you, no pun intended. So let's see what we've got here. I've got that picture credited. Let's talk about this MAC address. Now, I discussed this earlier, but I want you to see how the MAC address is arrived at now. And as I mentioned, you just have to get used to the networking. Some protocols, some services you're going to use in this course and future ones, they're going to have more than one name. And here, we've got an address that actually has 5 different names last time I counted. MAC address, the most common name, media access control address. Physical address, because the address physically exists on the network card. Remember, this is a layer 2 address. And there's the third term, layer 2 address. And let's see, burned in address, BIA, the name comes from the address being physically burned into the NIC, and then Ethernet address. Believe it or not, we used to have 7 flippin' names for this address, but I don't really see or hear the terms NIC address or LAN address, so we'll leave those alone. And really, for almost the entire course, I'm going to use the term MAC address. I don't say burned in address very often, very few people do, but you do need to know those names, because you'll see the Cisco router at one point is actually going to refer to the MAC address of a connected device or a port on that switch router as the BIA. Now, the MAC address is pardon me, is used by switches to send frames to the proper destination in the most efficient manner possible, and which sounds like a great idea. And we're going to see that happen in the switching section. But before we get there, I want to introduce you to the address format and the characters we're going to see in this address. The MAC address is 6 bytes long, or 48 bits, and can be expressed in either of the two formats on the screen. You could put dashes between each 2 characters. You could put periods in between each 4 characters. I've actually seen it where people use dots, to separate the 6 pairs of characters. None of those is wrong. You'll most likely see it the first way, but I just want to have you ready to see it any of those 3 ways. Now, MAC addresses consist of hex values, and if you're already sitting in your chair going, crap, here he goes about hex. I don't like hex. You don't like hex just because it's something we don't use, I should say, every day. And so when you don't use something or you don't really understand what's going on yet, that's when fear creeps in. I'm going to tell you point blank, by the time this section is over, and I do mean the course, and you get some practice in with it, you're going to be working with hexadecimal like a champ. It is going to be second nature to you. At any question about hexadecimal addresses on the exam, you are just going to nail it. But you'll hear me say this throughout the course, and I'll start now. The key to mastering anything with numbers, hex, binary, subnetting, it's practice. You can read about it all you want. You can see me do it all you want. You can see somebody else do it all you want. Learn a different method. I don't care. But you've got to get practice. Because, when you're in there taking the exam, that's your game. And why do professional players in any sport make a lot of the stuff look easy when it's actually incredibly difficult? They have the skills and they practice. You've got to get that practice in on this stuff. Now let's talk about the 2 parts of the MAC address. This is what I wanted to mention to you now. The first part of this address is the Organizationally Unique Identifier, or OUI. Don't pronounce it we. The OUI is assigned to hardware vendors by the Institute of Electrical and Electronics Engineers. And I think I used IEEE earlier and didn't mention what it stood for, so there it is now. The name is the recipe. The OUI is unique to that organization and is not assigned to another org. The second half of the MAC address is simply a value not previously used by the hardware vendor with that particular OUI. So if we look at that earlier MAC address example, AABBCC112233, you could be asked on the test, what's the OUI? Which part of this identifies the vendor? And it's simply the first half of the address, AABBCC. And we also know the vendor has not used 112233 with that particular OUI yet, so the vendor is doing so now. That's all there is to it. No mystery at all. Now, there's a special MAC address for broadcast frames, and as we get to that topic, I want to clarify these 3 terms because you hear them used a lot in our business, obviously. First off, unicast traffic. What does that suggest to us? It suggests one. Unicast traffic is traffic that is destined for one particular host. Multicast traffic, that's our middle ground, because broadcast traffic, destination for everybody, I'll change that to destined. It's destined for everybody. We want everybody to get a broadcast, just like a radio broadcast. We're just going to send this big old signal out, and we want everybody to get it. Well, that's pretty broad, no pun intended, but I mean, that's a lot. So maybe we have a group of people we want to get it, or a group of hosts. That's where the multicast comes in, because we needed a middle ground between broadcast, which is just sent out there for anybody to listen to, or unicast, which is destined for one particular host. The broadcast MAC address, be ready to spot this one on the exam, it's all F's. And it can be uppercase or lowercase, or even a mixture of the two if you really want to burn your retinas out. Case does not matter in hexadecimal. Doesn't matter. Small f has the same value as a big F. And if you don't know what either one of those stands for, you will. First, though, we need to go back and take care of a little business, because you remember that header and trailer I mentioned real briefly with Ethernet earlier? And you probably don't. Well, it was a fast mention, so I've got it here for you again. And I know I mentioned that even though our Ethernet and Gig Ethernet and Fast Ethernet, they all have the same format for the frame, header, data, trailer, there was a little bit of detail we needed to go into. And we're going to do that on the very next video. I'll see you there.